Today we study the Calculus 1. The topic is the mean value theorem for derivatives. So now look at the problem. We have the following geometrical fact. Look at the figure. It is a curve. In the pink curve, we can find it. There is a right line. How to write it? If the pink curve is smooth enough, we can find the right line parallel to next line of the A and B. How to find it? It is our question. So now look at this fact. In the picture, the pink curve satisfying y equals fx. The 2 points is little a and little b. There is a next line showing A and B. If FA equals FB, we can find there are 2 points, cos1 and cos2, satisfying corresponding there exist the horizontal tangent lines 1 and 2. They are parallel to the x-axis. How to find it? Yes, I know from the picture, the right horizontal tangent line, the corresponding f prime cosine equals 0 means the slope is 0. Now look at this fact. This figure, the pink curve, the equation is y equals fx. The 2 points is little a and little b. There are still 2 points, cos1 and cos2. If FA doesn't equal FB, if the curve is smooth enough, we can find the 2 right straight lines still parallel to the next line of capital A and capital B. You can ask yourself, if f prime cosine 0 equals 0? No. Why? Only parallel to the line A and B, not the x-axis. Of course, you ask yourself, how about the prime? Means, how about the slope of the right tangent line? So now look at the mean value theorem for derivatives. There are 2 conditions. Look at condition 1. If f is continuous on a closed interval from A to B, sometimes we can write it f belongs to continuous function on the closed interval of A and B. Look at condition 2. And f is differentiable on its interior little a and little b, means open interval. Sometimes condition 2, we will say f prime x exists on its interior from A to B at this time, and then there is at least one number. There is at least mean exists one number cosine in A and B satisfying where f from cosine equals fb minus fa over b minus a. Sometimes the equation written in this form, fb minus fa equals f prime cosine times b minus a. It is our mean value theorem. How to prove? From here, we can from the figure find it the theorem is true. Look at it. It is a curve, smooth enough. The 2 points, little a, little b. There exist 2 points, cos1 and cos2. We can find if fa doesn't equal fb, there exist 2 tangent lines parallel to cutting line through A and B. How to write it? Yes, f prime cosine is parallel to A and B, the black line. Corresponding the black line slope is 2-point formula equals FB minus FA over B minus A. From the geometrical meaning, it is obvious how to prove in mathematical language. Now look at our concrete proof. Let a new function gx minus fa equals, it is our k, means what? Slope. X minus a according to the basic form, the point-slope form. What is that point? Yes, the given point, AFA. Of course, you could write BFV. In this question, we write AFA means the given point. How about slope? Yes, the slope of 2 points, capital A and capital B. Write the K. K equals FB minus FA over B minus A. This is the new function. If let little s function equals fx minus gx, means difference of the two functions fx minus gx, taking in the expression for gx. Gx equals fa and then minus k bracket x minus a. So now pay attention to two values at the two endpoints. One is x equals a, taking in xa equals fa minus ga, fa x equals a, taking in x equals a, this term equals 0. fa minus fa minus 0, still 0. So sa equals 0. The similar meaning we can get sb still 0, means at the two endpoints sa equals sb equals 0. At this time we can get there exists, means there is at least one x belongs to AB, satisfying f prime x equals, what is our f prime x? Pay attention to this equation. Do the same computation. F prime equals f prime minus g prime, so equals this form. And then f prime, fa prime equals 0. This is our kx, k prime equals itself. So fb minus fa over b minus a, it is our s prime x. For x between a and b in Theorem point. Now select special point cosine, means there is at least one number. S prime cosine equals f prime cosine minus the constant equals 0. Why write the cosine? Taking the same variable. F prime cosine equals f prime cosine minus g prime cosine f prime cosine. Yes, taking in the same values. So we can get f prime cosine equals 0. So now we can write it f prime cosine minus k equals 0. So f prime cosine equals k. K is our constant. fb minus fa over b minus a. Pay attention to the formula. You can think about something about slope, means it is the slope of the connection line of parsing capital A and capital B. It is our mean value theorem. So now look at example 1. How to use the mean value theorem? We can prove some question. Now look at the question. Prove that arctangent x2 minus arctangent x1 less than or equal to x2 minus s1, x1 and x2 satisfying this equation. How to apply? Do you remember the basic? fb minus fa equals f prime cosine time bracket b minus a. So you have some idea between ab, x1 and x2. Think it in your mind? Yes, fx means arc tangent B minus arc tangent A less than or equal to some special value B minus A. According to this idea, we can let fx equals arc tangent x on AB means the closed interval. The idea is important, means the step is very important. From the given equation or given question, we can find how to let fx. In this question, fx equals arc tangent x. So now, by the mean value theorem for derivatives, we will have fb minus fa means arc tangent b. What is our b? Yes, x2 is our b. What is our a? A is x1. So corresponding arc tangent x2 minus arc tangent x1 equals what? Bracket b minus a. B means x2. A means x1. So x2 minus x1. So now look at this term. F prime cosine. What is our f? This function. F prime equals 1 over 1 plus x squared. So now means f prime cosine corresponding variable taking in the value cosine. So f prime cosine means 1 over 1 plus cosine squared. You pay attention to the step, how to write it f prime cosine. From here, we can get some new results. Pay attention to cosine. Cosine between A, B means x1 and x2 because 1 over 1 plus cosine squared less than or equal to 1. You ask me why? Because cosine squared is a positive number. 1 plus non-negative number less than or equal to 1 over together less than or equal to 1. And then we can get arc tangent x2 minus arc tangent 1. Our left right less than or equal to 1 time x2 minus x1. Together, it is the final result. Arc tangent x2 minus arc tangent 1 less than or equal to 1 time x2 minus x1. How to using the idea? Pay attention to let fx. Try to find the function fx expression. So now using the idea, do our example 2. Prove light. Line bracket 1 plus x between the two values, and if x is a positive number. Maybe the question is difficult. Learn example 1. How to understand? In example 1, we write arc tangent B minus arc tangent A. How to think about this question? Arc tangent f prime, yes. Let fx equals line bracket 1 plus x. On the given closed interval, what is a given? This condition, x less than 0, give you some idea. Little a is 0, little b is x. So fx equals line bracket 1 plus x. On the closed interval between a and b means 0 and x. X is a positive number. The idea is very important. If you know this idea, you will do these steps for yourself. So now we together. By the mean value theorem for derivatives, we have fb minus fa. What is our b? B is x. So fb means fx minus fa. Fa means f0 equals f prime x times b minus a means x minus a. Cosine between a and b. Cosine between 0 and x. According to the basic mean value theorem, we can write it out. And then analysis. How to write it? Look at f0. What is our f0? f0 means the value function at the given point 0. f0 equals ln 1 plus 0. Ln 1 equals 0. So f0 equals 0. And then fx itself equals ln bracket 1 plus x. How about f prime cosine? We should know f prime x. So f prime x equals 1 over 1 plus x. Of course, we know f prime 2 equals 1 over 1 plus 2. F prime 6 equals 1 over 1 plus 6. So f prime cosine equals 1 over 1 plus cosine. So we have ln 1 plus x minus 0. The left side equals ln bracket 1 plus x equals this term x. This term 1 over 1 plus cosine together x over 1 plus cosine. So now we know the concrete expression for ln 1 plus x. We will do some work for 1 plus cosine according to what? According to the domain. So now, cosine between 0 and x. Cosine between 0 and x. In this question, x is a positive number, plus 1. 0 plus 1, let's learn cosine plus 1. Let's learn x plus 1. Together, get this. Positive number, positive number, positive number. We can get this formula. 1 over 1 plus x. Let's learn 1 over 1 plus cosine. Let's learn 1. And then pay attention to time x. Time x, time x. Together, they are equal. So we can get this expression, every term time x equals this term. Pay attention to the middle term. Middle term means x over 1 plus cosine. This term is our ln 1 plus x. So together, get it, this result. So in this question, you should pay attention to how to get our fx. If we know fx, how to make about our 0 and x means little a and little b. If you have no idea, the question proof is very easy. So now we have our summary about the mean value theorem. The basic theorem tells us this expression. F prime cosine is some slope for convex line of parsing capital A and capital B, the points. FB minus FA over B minus A can be written in other forms if cosine between A and B. So now, look at case 1. We can write it in this form. FB minus FA means the difference of the two function values equals some prime. At some given point time, the difference of the two variables means times b minus a. If a less than b, the formula still holds. Case 2, we can write it another form. Special case, if b equals x plus delta x, a equals fx. At this time, we can write fb minus fa equals f prime cosine copy. How about b minus a? In this question, b x plus delta x, a x, the difference, the two values equals delta x. So equals f prime cosine times delta x. Pay attention to cosine between a and b. It is of the interior point. Look at case 3. Delta y means the increment of the function value. Delta y equals f prime cosine times delta x. How about delta? We can write it x plus theta times delta x. Theta between 0 and 1. The delta y means the increment of the function, means the accurate expression of the increment of delta y. How to write this term? There are some relationships between cosine and least expression. Pay attention to cosine between x and delta x plus x. So cosine some interior point between the end points. So cosine equals x plus some delta x times some constant. X plus delta x times some proportion, some ratio. How about the ratio? Yes, the ratio between 0 and 1. Pay attention to theta equals 0. Theta equals 0 means the left end point. Theta equals 1 means x plus 1 times delta x, the right end points. Try to understand the three different forms. So now, using the mean value theorem, finish out the question. Look at the question. Prove question. Prove arc sin x plus arc cosine equals half pi x between -1 and 1 to close the interval. How to prove? Now look at, we can write it. Let the function f(x) equals arc sin x plus arc cosine x. X corresponding to the domain is -1 and 1 to close the interval. How to write it? f(x) always equal half pi. What it means always equal half pi? Corresponding, do you remember c prime equals 0? So we try to get f prime corresponding f prime x. Arc sin x equals 1 over square root 1 minus x squared. Do you remember arc cosine x corresponding minus 1 over square root 1 minus x squared? They are the same expression. Difference are positive minus. The together summation equals 0. F prime x equals 0. How about fx? What kind of function prime equals 0? Yes, fx equals c forever. For every x, always equals c. Fx equals c for our real number x in the given domain. How to understand this question? This means x equals 0, fx equals c. X equals -1, fx equals c. X equals positive 1, fx 0 equals c. So we try to find the c. So now, taking special point 0. f0 equals arc sin 0 equals arc cosine 0. We can get f0 equals this. Do you know this? Yes, arc sin 0 equals 0. How about arc cosine 0 equals half pi together equals 0 plus half pi means half pi. From this expression, we know f0 equals half pi. This means capital C is half pi. It is a constant. fx always equals c for every x. So together, arc sin plus arc cosine equals half pi. Try to remember this formula. Prove by yourself in the similar way. Arc tangent x plus arc cotangent x equals half pi. If x is any real number, means the domain is our real number system. So now look at this question. The question is, try to find the c. C means some concrete number. For fx equals double square root x on the 1 to 4, the closed interval. How to find the c satisfying the mean value theorem? We can find it. F prime x equals 1 over square root x. Okay, we know the basic formula f prime, and then fb minus fa over b minus a. In this special case, a equals 1, b equals 4. So f4 minus f1. f4 means double square root 4 means 2 times 2 equals 4. Minus f1. f1 means double square root of 1, so minus 2 over b minus a, 4 minus 1, so equals 3. Together, the value is 2 over 3. Try to find c satisfying f prime c equals 2 over 3. So we must have f prime c equals 2 over 3. What is our f prime c? Look at this. F prime x means for every x in the given domain, always equal 1 over square root corresponding value. So prime c square root c, prime 2 square root 2. In this question, f prime c equals 1 over square root c equals 2 over 3. C is some interior point between A and B. So for this equation, we can get the singular solution, means the singular point is C equals 9 over 4. The question means how to find the concurrent point psi. In this question means C satisfying our mean value theorem. Try to understand the theorem. So now class is over. See you next time.